The flight of Starship represents an extraordinary milestone in the field of space exploration. It is the largest and most powerful rocket ever built by humanity, launched by SpaceX. So far, Starship has been launched 5 times, with the first 4 launches demonstrating significant progress in this remarkable technology. Starship reached space during all 4 of these launches, but it has yet to achieve orbit. This brings us to the question: why has Starship, despite surpassing 100 kilometers in altitude, not yet entered orbit? Reaching space, technically speaking, means surpassing 100 kilometers in altitude, a distance marking the boundary between Earth's atmosphere and outer space. This value, known as the Kármán line, is recognized by the scientific community. However, crossing this line is not enough to achieve orbit. Earth's orbit also requires significant tangential velocity, which is lateral speed relative to Earth's surface. This velocity allows a rocket to maintain a circular motion around the Earth without falling back. While Starship has reached space, it has not yet achieved the velocity necessary for stable orbit. The flight that could mark a pivotal step in Starship's journey to orbit might be the 6th flight. This flight, though it appears similar to the previous ones, could be the first to take Starship into stable orbit thanks to crucial upgrades and tests. Let's explore the modifications and innovations planned for the 6th flight. The 6th Starship flight will have a profile very similar to the previous one conducted on October 13, but with some technical updates and changes that could radically alter its significance. The purpose of this flight remains unchanged: the mid-air capture of Booster 13 and the splashdown of Ship 31 in the Indian Ocean. However, SpaceX has made critical adjustments. Notably, the most important test will be the ignition of the Raptor engines in space, a decisive trial for Starship's future. Additionally, re-entry will occur at a steeper angle than in previous flights, increasing stress on Starship's underside, including its wings. This new re-entry configuration could lead to plasma infiltration at the lower wing hinges, a phenomenon previously observed on the upper wings. To counter this, improved materials will be tested beneath the heat shield tiles. SpaceX aims to determine which of the 2 materials performs better under the heat and forces generated during atmospheric re-entry. One of the most challenging aspects of this flight is managing propellants in space. Like any rocket, Starship has fuel tanks that feed its engines, but in the vacuum of space, there is no gravity to push the fuel to the bottom of the tanks. This creates a significant challenge for engine ignition in space. To address this, SpaceX has designed auxiliary tanks called header tanks, located at the top of Starship, to maintain fuel flow to the Raptor engines. This system was designed for re-entry and splashdown maneuvers, but it's unclear whether it will also be used for the in-space ignition test. SpaceX must also address tank pressurization using inert gases like helium to ensure the fuel can be drawn and fed into the engines. The mid-air capture of Booster 13 represents another crucial step in the Starship program. SpaceX expects Starship to perform this maneuver within 6 months. However, to reach this milestone, SpaceX must overcome a series of technical tests, including the ignition of the Raptor engines in space. Starship must also be able to perform orbital maneuvers before returning to Earth, requiring advanced control capabilities that only the Raptor engine can provide. Starship is a massive rocket, 50 meters tall, 9 meters in diameter, and weighing tens of tons. Bringing such a large spacecraft into orbit involves enormous risks, especially if atmospheric re-entry cannot be controlled. In the past, SpaceX has conducted tests with Starship, but the failure to ignite the Raptor engines prevented the completion of an orbital cycle. If SpaceX had attempted to send it into orbit without properly functioning engines, 3 negative scenarios could have occurred. 1. The Raptor engine fails to ignite. Starship would be stuck in orbit and eventually re-enter uncontrollably. 2. Re-entry becomes uncontrolled after ignition. Poor engine management could result in an imprecise re-entry. 3. A catastrophic ignition. If the Raptor engine exploded, it would create space debris and irreparably damage Starship. Each of these scenarios is extremely dangerous and underscores the importance of the test to be conducted during the sixth flight. Only with the success of this test can Starship take the next step, achieving stable orbit and safely returning to Earth. With the next test, SpaceX plans to launch the Starship V2, now called Block 2. While there is little official information, it is certain that Starship Block 2 will represent an advanced phase of the program. In 2025, SpaceX aims to conduct about 25 Starship launches, with the ultimate goal of launching one Starship every 2 weeks. By 2026, the company hopes to exceed 100 launches annually, accelerating the space exploration program. Starship is not just a rocket for transporting satellites but is intended to become a vehicle for much more ambitious missions, returning to the Moon, colonizing Mars, and beyond. A critical element for Starship's success will be its ability to transfer propellant between spacecraft, an operation necessary for longer and more complex missions, such as those to the Moon or Mars. The sixth Starship flight, while similar to the previous one, is a crucial test for SpaceX. If successful, it could bring Starship into orbit for the first time, paving the way for future missions and marking the beginning of a new chapter in space exploration. The test of the Raptor engine ignition in space and propellant management will be critical trials for the rocket's future. Only after successfully completing this test can SpaceX consider orbit a reachable goal for Starship. Don't forget to subscribe to the channel and turn on notifications to stay updated with future videos.